Okay, we begin with this. Please write this down, applications to economics. We're in section 4.9. Okay. Economics is concerned with profit, cost, revenue, pieces like that. And the first thing we're going to define is this. C of x is going to be our cost function, okay? Our cost function. And if you remember from a ways back ago, we took the first derivative and we found that c prime of x would be what we would call the marginal cost function. Now, do you remember what it means to be a marginal cost function? Do you remember what that tells us? The cost of producing the next item. So let's write that down. Okay, so let's switch gears just temporarily. What you can see here is that C prime is the marginal cost function. That tells us the instantaneous rate of change, which would be the instantaneous slope at that point, which would be the increase for the next item, or the cost of producing the next item. Let's think about this, average cost. If I want to figure out the average cost of production, now let's think about this for a second. Let's say it cost me $20 to produce an item, the very first one. By the time I produce the 500th item, do you think it would cost me $20 to produce that item? More than $20 to produce that item? Or less than $20 to produce just that item? Much less. Why? Yep. You don't have the beginning cost. It is the mass production is going to, reduce it. So we would like to produce more things at once. For example, just very basic, I like to do woodworking, and I like to make different things. And I last made a quilt rack. I showed you guys there. We've been here before. Sometimes what I'll say is, I don't want to go through all the work of setting up and getting ready to do this for one quilt rack. So I'm going to make 3. And then I guess I'll just house them and give them away as gifts later on. Because I'm much more, yeah, oh yeah, I do that stuff. So you're laughing. No, now you're laughing. So, um, see, Stuart, this is what you couldn't hear. You couldn't hear the ridiculing of their teacher. If we would find the average cost, we would take the total cost and we would divide it by the number of items. Average cost would equal the total cost divided by the number of items that we in fact produced. So let's write an expression for this. Okay, average cost. What is the total cost? What's our total cost function? C of x. What does C of x mean? Somebody tell me, what does C of x actually mean? Cost of producing X items. So how many items have we produced? X. So our average cost function is simply C of x over x. Okay, I'm going to call that small c of x. So just want to make sure I got my notation right here. We're going to call that small c of x, okay? Small c of x. So the average cost function is equal to the total cost divided by the number of items produced, okay? Now, often within economics, would we like to minimize cost or maximize cost? Minimize cost, okay? And minimum values, how did we find minimum values using differential calculus? When in doubt, take the derivative, and minimums occur where the derivative is equal to 0. So let's just think about this. We want to minimize the average cost of production. So I take the derivative and set it equal to 0. Let's do that. Small c prime of x is equal to, how do I do with that? C of x over x. Quotient rule. Quotient rule says I take the derivative of the top, which is c prime of x, times what? Large c and little c. Little c is the average cost. Big C is the total cost. Okay. You guys, you will not have to reproduce this. I want you to see where it comes from instead of just giving you a formula, okay? So we're almost there. So I take the derivative of the top, which is c prime of x, divided by, times the bottom, which is x, minus the derivative of the bottom, which is 1, times divided by what? X squared. Now, you guys told me that we want to take that derivative and set it equal to 0. So 0 over 1 is equal to c prime of x times x minus c of x all over x squared. Cross multiply, what do I get? Times x minus c of x. Look, watch what I'm going to do here, okay? I'm going to subtract this or add this over. I get c of x is equal to c prime of x times x. And if I divide both sides by x, here's what I get. C of x over x is equal to c prime of x. Now, let's just think about what this means. We're done. What is c of x over x? Average cost. What does c prime represent? Marginal cost function. Very good. Um, Morgan asks a very good question, and it really revolves around this. When can the average cost function equal the marginal cost function? We're going to find that out. But when it does, that's where we have minimal cost. I want a quick review how we got that, and then I want to do an example, and you guys will be good to go. Now, you don't have to duplicate this, but let's just understand where this came from. Cost function, marginal cost, amount of producing the very next item we take the derivative. We identified the average cost as such. All we did is we used the quotient rule to take the derivative, we set it equal to 0, and we came up with an expression that said average cost function equals marginal cost function. That's when we have a minimal cost. And so that's going to benefit us, okay? So here we go. Example 1. You're going to need your calculators. Okay. Cost of producing X items is C of X equals 2,600 plus 2x plus 0.001x squared. Now, the questions are as such, okay? Find the cost, average cost, and marginal cost of producing 1,000, 2,000, and 3,000 items. Now, for example, this is the cost, okay? Let's now look at the other pieces we need. Marginal. And the, what else? Average. So the first key is, can you generate these functions? Who can tell me what the marginal cost function is? Very good. So Ashley was able to identify by taking the derivative that that is our marginal cost function. Our average cost function we will write as small c of x, and that's equal to what? The, the top one divided by x. The average cost function is equal to the total cost divided by the number of items that you're producing. Now, Sean is right that we want to set these equal to each other eventually to find that minimal spot. But my first question is, find the cost, average cost, and marginal cost of producing 1,000, 2,000, and 3,000 items. Let's just do 1,000 items. Okay, 1,000 items. Okay. Yep. I want all three. I type it in. As opposed to going to y equals, because I'm not actually going to do this more than once. I'm just going to just do this one time. So I will go 2,600 plus 2 times 1,000 would be 2,000 plus parentheses 0.001 times 1,000 squared. Yep. So total cost is $5,600 to produce that number of items. So that's total cost. Average cost, I don't need to plug it into my calculator, do I? In order to figure out the average cost, I would take the total cost, which was $5,600, and divide it by what? 1,000. So the average cost would be $5.60 per item. If I want to figure out marginal cost, where do I plug the 1,000 in? Right here. If I take, yep, if I if I plug in 1,000 times 0.002 is going to be 2. So if you just try it, 2 plus 0.002 times 1,000, I believe we get 4 out of that. So let's help each other understand here really quick. Somebody explain for me, what does it mean that the total cost is $5,600? To make all 1,000 items cost me $5,600. What does it mean that the average cost is that? Yeah, if you were to say on average, I guess each item cost me $5.60 per. So why is the $4 lower than the average? The more you produce, the cost to produce each one is going to go down. So marginal cost means to produce the 1,000 first item will be approximately $4. The average cost to produce 1,000 items is $5.60. Yes, and then marginal cost would be, yes, $4. The marginal cost of the 1,000th item is $4. So the cost to produce the 1,000 first item would be $4. So, okay, excellent. Second question, at what production level is the cost the lowest? Okay? At what production level, what will the average? At what production level is the average cost the lowest? So, you may say, well, we'll continue to just, produce 1 billion items. Well, they're saying that there's some spot where, you minimize that average cost. And that's a difficult question. That's why we went through the previous stuff. That's why we went through this previous work to be able to say the average cost function, when it equals the marginal cost function, that's where we have minimal cost. So in order to answer this question, you need to take that average cost, set it equal to marginal cost, and solve. So let's do that. My average cost function is what? 2,600 plus 2x over x equals, what's my marginal cost function? 2 plus 0.001x. Oops, sorry. I need to solve that. That will tell me when the production is going to be the lowest. I'm sorry, when the average cost is going to be the lowest. That's what we did. We did that in order to say this. Okay? So this is my average cost equals marginal cost. When we find when the average cost is equal to the marginal cost, that's when we have a minimum, and that's where we minimize our average, okay? So that's what we want to do. How do I solve for that beast? What are you going to do? Okay, multiply both sides by x, so I have 2600 plus 2x plus 0.001x squared equals 2x plus 0.002x squared. Right? I'm going to gather all my terms on one side. I'm going to subtract 0.001x squared over here. Notice my 2x's cancel. And I'm going to subtract my 2600 over the other side as well. I get 0 is equal to 0.001x squared. I guess I probably should have subtracted 2600, should I? Let's leave it over there. Sorry. If I would have had a middle term, then I would have wanted to subtract that over, but I don't have a middle term. Divide both sides by? Divide, you get 2,600,000 is equal to x squared. If I square root both sides, 1,612. No. You could round to the nearest number. Yes. Yep. So I have 1,612 items. If they then ask the question, how much would that cost you total? What would you do? You plug that into your total cost. What if they said, what's the marginal cost of that? And you plug it in there. What if they said, what is the average cost of producing that number? You'd plug it into there. And again, the marginal cost and the average cost should be the same. That's exactly what we solved for. That's the process, okay? All right? I want you to try working on a couple problems. You have 15 minutes. You do want to get started on this now. You do not want to wait on this. You'll get confused. Because you guys, tomorrow, we work through demand and revenue and profit functions, which are slightly more confusing, okay? Yep. Page 293, numbers 5 through 7.